Today we've got a long lesson and the focus is pseudocode, so we're going to look into it in a bit more depth. Starting with data types, the kind of data types you need to use at AS level. We're then going to look at a data structure which is called a record structure and how it could be used to hold multiple different types of data. We're going to be looking at arrays, the technical terms associated with arrays, and also practice writing the pseudocode, which is obviously the more essential part. So if some of these are pretty straightforward, you might want to speed things up. I'll leave that up to you, but I would probably suggest go through it. Let's start by looking at the key terms that are involved with this part of pseudocode. So how do you define a data type? Pause the video, jot these terms down. I'll go through them anyway, so if you've written them up and you're comfortable with them, then you might want to skip this part. Okay, so let's look at a data type. A data type is a classification attributed to an item of data, which basically determines its value, what it can store and how it can be used. So a string, as we know, is a common data type. What that means is that you can have any combinations of letters, numbers or symbols, and you can use it for those purposes. For example, you can probably apply string functions to it rather than calculation functions to it. An identifier is a unique name given to an item of data. Basically, it's a variable name. At AS level, we call it an identifier. Record perhaps is a new data type that you might have encountered at AS level. It basically is a composite data type consisting of several basic data types. So if string and integer are basic data types, you can create a record which can hold two values. One of them could be a string, the other one could be an integer. Now you can't do that in base data types, but you can do that using a record data type. So what does composite mean? Well, a composite data type is a user-defined data type. That means we make it up and it's not inbuilt into the programming language. It's a user-defined data type that's made up of several basic data types, example integers and strings. So straightforward record is something that we will create. For example, you might want to store a book record which has the name of the book, which could be in string format, and you might have a price which could be in real format. So two basic data types could be used to construct a new composite data type. Therefore, non-composite data types are user-defined data types which are made of the same data type. So composite basically means a compound in a way, which is a mixture of different elements, and non-composite basically is the same element or the same data type. An array is a data structure which is like a list containing several elements of the same data types. An array will have an index, which is a numerical indicator of a data item's position in the array. So at index 0 you might store a name, and index 1 it could be a different name. And similarly you have new two terms which are lower bound, which is the first element of the array or the first index of the array. So in this case index 0 could be the first one, and the upper bound is the index of the last element of the array. So if your array had 10 items, you might have index 0 could be the lower bound, index 9 would be the upper bound. So when we are referring to arrays in exams, we use index, lower bound and upper bound, and that's the language they will be using to express arrays. So let's start by looking at common data types. Now you should be familiar with these ones from IGCSE. Boolean, logical values, true or false. In pseudocode we write that in capitalized Boolean. In Python it's normally called bool. Then you have char, which is a single alphanumerical character. Char in capitals, and it's not used in Python. Date is a value to represent a date, and in pseudocode we refer to that as capital date, and in Python you normally use a class which is called datetime. Integer is normally used to store whole numbers, positive or negative, and integer in pseudocode is exactly that, integer in capitals, and in Python we call it using int. Now we don't use floats at AS level, we use the data type real. So this is used to store positive or negative real numbers and referred to as capital real in pseudocode. In Python you do use float, but remember, if the question is asking you to explain that in pseudocode, then you need to use real and not float. And finally, you've got string, which is a sequence of alphanumerical characters. Pseudocode capitalize string, and in Python str in lowercase. An example of a common data type and how to declare it is declare my birthday colon date in capitals, identifying the data type. Just remember, declaring an identifier requires you to use declare in capitals, then the name of the identifier, which is basically the variable name, colon, and then the data type, which will be in capitals in pseudocode. So just get familiar with that notation. So what's a record data type? Well, we know that it's a composite data type. It's user defined. It doesn't exist until you define it as a programmer. Once defined, it can be called and used in the usual way. So to start a record data type, you start with type in capitals, and then you give the name of whatever the record is. So in this case, we're going to create a book record. We're going to call it T book record. Why do we use that notation? Because T identified is a custom type. Book record is obviously the name of that record. Now in this record, we're going to have several other data types. So we're going to declare title as string, author as string, publisher as string. We're going to declare no pages or the number of pages as integer. And then we're going to declare fiction, which is a Boolean. Is the book fiction, yes or no? And type to let the programmer know that we have finished defining the book record. Now once we've got this custom record data types, we can call it in the same way. So we're going to start a new instance. In this case, we're going to say declare book, but instead of being string, the book will be the T book record data type we've just created. You can then define the book's author by assigning book.author, the actual attributes which is in the T book record. So it's kind of like classes and attributes. But in this case, it's not a class because there are no methods or procedures associated to T-book record. The only thing you can do is basically call the attribute. So book.author, we can give it a value. Book.fiction, we can assign it a value according to its data type. So pretty straightforward. What you might want to do is try to see if you can code it. Right, so one-dimensional arrays are non-composite data types. Basically means they store the same type of data in them. They use an index. They also have a lower bound, which is classed as the first element of that index. In this case, it will be 0. And then you also have upper bound, which is the last element. In this case, that would be 8. Remember, we're just referencing to the index elements and not the actual data. So in pseudocode, we'll declare an array by simply saying declare my list colon array. In the brackets, we give the dimensions of the array, so 0 to 8, and this is going to be of the type integer, so we say of integer. Similarly, if you want to define a value or assign a value to an element in that array, we simply say my list bracket, which is a square bracket 7, and then we assign a value of our choice to it. Two-dimensional arrays are similar. They're again non-composite, so that means the same data type. However, these use a row index and a column index, so they act like a grid. So in this case, lower bound is the first element and upper bound is the last element, and you can have a lower bound row element and an upper bound row and the lower bound column and an upper bound column as well. So technically you could have 0, 0 as the lower bound and 8, 2 as the upper bound in a two-dimensional array. And it's declared exactly the same way. So declare my array colon an array. In square brackets you will have it's two-dimensional. The row index is 0 to 8 and the column index is 0 to 2 of integer type. And then when you want to assign a value, you will say my array square bracket 7, 0, row column, and then you assign the value 16 in the example that's shown on screen. Your task is that in Python you should be creating a record structure of your own choice. Get the user to input data into that structure, and then you should be able to output the complete record. If you've done the one-dimensional array, you might want to then move on to a two-dimensional array, where you create a 2D array of your choice, try to do a minimum of 5 by 5, and then use a for loop to populate it by incrementing numbers starting with 1000. You should probably end up with a grid where you start up with 1000 and then go all up to 1024 or equivalent, and you should be able to display this grid automatically in your program. So 2 programs to do. They will probably take you about half an hour to do, unless you're very well versed with Python. So take your time, do that, and then continue on with the remainder of the lesson. That takes care of arrays. The next part of this particular lesson will focus on an understanding of what an abstract data type is, which is basically a collection of data and a set of operations on those data. You need to show an understanding that a stack, queue, and linked list are examples of abstract data types, and you should be able to describe key features of stacks, queues, and linked lists and justify their use for a given situation. Now, you don't need to know the pseudocode for this, but you should be able to add, edit, and delete data items from given examples of stacks and queues and linked list. You should also be able to describe how a queue, stack, and linked list can be implemented using arrays. So this builds on the array part of the lesson. Now, abstract data types are a collection of data, but they're different because you can have a set of operations that you can apply to them. And our first one is a stack, which is a list containing several items using the last in, first out approach. So that means the last item that comes into a stack, it's the first one to go out. So imagine a pile of bricks. When you start, you pile a brick at the bottom, then you put another one on top, and then another one on top, and so on. But when you want to remove them, you will take the first item, which is the brick that you put on last at the top, and you take that out first, and so on. We'll talk more about that in a moment. Queue is another one. Queue is like a list containing several items using the first in, first out approach. So that means the first brick that you goes in, that is the one that will come out. And the final one is a linked list, and this one is a list containing several items in which each item points to the next one on the list. We'll talk more about linked lists in due course. For now, just pause the video and get these definitions down somewhere. Okay, let's look at stack. A stack is a list containing several items, and obviously it uses a last in, first out principle called LIFO for short. Items can be added, pushed into the stack, and items can be removed. That means popped out of the stack. That's the terminology you need to know. So be familiar with push and pop. Push, items added; pop, items removed. Now, the first item that's added to the stack is often the last one to be removed. And stacks are everywhere. Your browsers, history, when you use the navigation buttons to go backwards and forwards, that's basically a stack. When you're trying to do a calculation, that's basically a stack. Stacks can be implemented by creating an array and having 2 variables acting as a pointer. So the first one is the base pointer, which points to the first item of the stack, and then you have a top pointer which points to the index of the last element in the stack. And these can be incremented by just totaling and adding a value or subtracting a value. Now, queues, on the other hand, operate differently, but the structure is similar. So they're normally a list which contains several items, but the principle that they use is first in, first out. Then items can be added and queued, and items can be removed, dequeued. So again, be familiar with the terminology. So if in an exam question you're asked to dequeue an item, that means you're removing an item. Or if you want to say the kind of methods that, remember, abstract data types can use methods. What kind of methods would a queue data type have? They would have enqueue, which means you're adding an item to the queue, and dequeue, which means you're removing an item from the queue. The first item added is always the first one to be removed in a queue, which is a bit different from the stack. You can implement a queue exactly like a stack. You can have an array and 2 pointers. Pointer is going to be the front pointer and the end pointer, and the front pointer is going to always point at the first item, and the end pointer is going to point at the last item that is in the queue. So if you want to add a new item to the queue, you just update the end pointer and add +1. And if you want to remove an item from the queue, you take the front pointer and you add 1 to that, so the pointer moves to number 2. You don't even need to delete the data. A linked list is a bit of a different structure. It's a list containing several items, and each item points to the next item in the list. So if you think about an array would just have the items in whatever order they come in. A linked list could be used to sort things out in the right way. So each node will contain 2 pieces of information. One is the data, the second is the pointer, which points to the next item on the list. So we have a start pointer, which will always point to the first item or the first node and say, well, 27 is the first one. Then when you enter 34, the node of 27 will point to 34, and it will say that that's basically where the second item is. Now then you add 82, fair enough, that will mean that 34's pointer points to the third item, 82. But what if you then added 79? Now the list needs to change. So what will happen is that you will change the pointer of the second item and say, well, the next item on the list is going to be the 4th one. And when you go to the 4th one, the pointer of that is changed to point that the final item is going to be the 3rd one. And then the 3rd one, because there is no more items after that, will just in the pointer have the value null. It's basically called a null pointer, and null means that there's no more values in the linked list, and that denotes the end of the list. Now we will look at linked list and all of these in a bit more detail later on, but let's just stop and look at what all these pointers are all about. Stacks, queues, and linked lists all use pointers, and a stack uses 2 pointers, a base and a top of the stack pointer. When they're equal, then that means there's only one item in the stack. And a queue also uses 2 pointers, a front pointer and a rear pointer, and when they're equal, that means that there is only one item in the queue. Linked lists use a start pointer, and each data item or element is also stored with a pointer, and collectively they are known as a node. The last item, obviously, as we just mentioned, is a null pointer, which signifies the end of the list. So what is a pointer? Well, pointer basically is a memory location or an address, and that's all there is. So when you create an array, you are just pointing out where the next item is stored, and we can allocate that by using simple variables or identifiers. Now stacks have certain operations which are push and pop. So look at the example on screen. In an exam question, you're going to be given similar diagrams where the base pointer is going to be probably pointing at index 1 and the top pointer is pointing at index 4. So if you want to remove the value associated with index 4, which is value 79, then we're going to use an operation called pop, where we move the top pointer to 82, which is index 3. So we're just simply subtracting 1 from the value of the top pointer. So 4 minus 1 gives you 3. And that's the process that you will use for pop. When you want to add a value, so let's just say we wanted to add a new value, 31, after we removed 79, we will have to use the operation called push. So you can create a procedure where you simply take the top pointer and add 1 value to it. So that's +1. The pseudocode for all of this is on screen. So pause the video and have a look at how we set up a stack, how we add an item using push, and how we remove an item using pop. Now to set up a stack, you simply declare the stack as an array. You then define the top pointers and the base pointers as integer, because you're just subtracting index or adding index values. And then you have a Boolean flag, or you might have an integer which declares when the stack is full. So you can assign values to these variables. So the base pointer can be given the value 1, the top pointer can start at 0, and the stack full will be when it hits the value 10. Now there's lots of different ways of implementing it. This is just one way, so the pseudocode that you might want to write could be a bit different. but there could be a Boolean field which identifies when the stack is full. Lots of ways to go around it. So when you're creating the procedures to push or pop an item, that basically just includes an if function where you just compare the pointers and either you add or increment one, or you remove or decrement one, depending on whether you're pushing or popping. So it's a basic if statement. Pause the code and understand this before you move on to the next section. Okay, so how do we code a stack? Well, in Python, it's pretty straightforward. You can use an array, you can define your variables, and then you can create two functions or definitions, one for pushing and one for popping, which can be accessed outside of those definitions. Pause the video, look at the code, and try to create a REPL or your own Python code in your own IDE and try to create this stack operation. Now, a typical exam question might look like what you see on screen. Look at this particular stack, there's a few values, show the stack and the value of the top pointer and base pointer when an item has been popped off the stack. So that's the first part. The second part is add 67 followed by 82, which need to be pushed onto the stack. So you've got three stages and you need to give the top and the base pointer after the third stage. So take a value out, that means remove 21, add 67, add 82. What's the value of the base pointer? What's the value of the top pointer? It doesn't require any code, it just requires you to work out some basic arithmetic. So pause the video and hopefully work out the solution. Now queues work almost similarly, and we operate on the other end of the queue compared to the stack. So in this particular case, you've got a queue where you have a front pointer which points to the first item in the queue and a rear pointer that points to the last item on the queue. So when we're removing an item, we simply take the front pointer and add 1 to it. And similarly, when we're adding an item to the end of the queue, we take the rear pointer and add 1 to it. Just be aware that queues could be implemented depending on their index numbers. So if the index, for example, if the queue is in reverse order, then you might need to subtract things. So obviously if the front of the queue is in position 7 and the rear is in position 4, then you would need to decrement it. So always look at the index in the question. So let's look at a queue's problem. Now a queue can be full, and what can happen is that eventually the front and the rear pointer end up at the bottom of the queue at position 10, and that means that there's only one item and you can't add more items to the queue because you're just adding 1 to the front pointer and it goes all the way up to 10. The rear pointer also ends up at 10 somehow. So to eliminate that problem, we can have a circular queue, which means that the front pointer, when it reaches the 10 and we want to add a value, the rear pointer moves to the beginning of the list. Now in this particular example, you will see that the front pointer is at 10. We removed a few items, we ended up at 10, but we also added a few items. So the rear pointer, when it hits 10, goes back to 1 and then keeps going downwards 2, 3, and so on. And that's basically what we mean by a circular queue, that the front pointer will change position when it hits a particular number, and the rear pointer will change the position when it hits a particular number, which is the end of the queue. So think about this. When we remove an item now from number 10, we move the front pointer to the first item, which is index position 1, and then we want to add another item, the rear pointer continues on. So at some particular point, you would need to use a selection and a condition that if the front pointer reaches this value, you change the value of the front pointer to another. How does it look like in pseudocode? Well, here we are. To set up a queue, same kind of process, declare an array, declare your variables, have a queue full variable and a queue length variable, that's to implement the circular motion, define a few values, start pointer or the front pointer at 1, end pointer at 0, because there's no item in the list, upper and lower bounds, and so forth. And to onQueue, we use an if selection again, that if the queue length is less than the queue full, then you have a nested if function working which increments the pointers, otherwise they refer back to the initial pointer. And dequeue works in a similar fashion. So pause the video, see if you can understand the pseudocode before you move on. Now to code a queue in Python, you need to apply a similar approach as a stack. A queue is basically an array or a list. You have your variables front and rear pointers, your queue full and your queue length. You have two definitions, one's called onQueue, the other one's called dequeue, and then using nested if functions you code it. So pause the video, look at the code and try to see if you can implement this in Python before you move on. Now, a typical exam question is similar to the stack one. So here you got the front pointer pointing at position 8 of the index, a rear pointer at position 3. Straight away you know that this is a circular queue. Now you've got to show the value of the pointers when 3 items have been removed or dequeued and 25 followed by 75 have been added to the queue. So make sure that you keep track of how the pointer is evolving when we look at the rear pointer, and we're looking at the front pointer. When we remove 3 items, the front pointer will probably move to 55, and when we add 2 more values, the rear pointer is going to go to index position 5. Now linked lists can be implemented as 2 one-dimensional arrays, and since arrays are finite, just like circular queues, we need to update both pointers. Now items can be removed from anywhere, and the empty positions needs to be managed using an empty list called a heap. Okay, so basically you will have one array to store the data of the node and the other to just store the pointer value for that data item. Okay, 2 arrays, pretty straightforward to implement. So you have one array which has an empty linked list pointer element, so the one on the right just stores that 0 value points to 1, the 1 points to the second in the empty linked list, which is where you're going to store your data items. So once you store values as they come in, the first value will be stored at position 0, and that means that the second value is currently pointing at position 1, but it could be changed. Now let's start with the data item. So we're going to add the value 37. So the start pointer is going to point at index 0 because that's the start of the linked list, and the heap pointer will say, well, the next available space is in position 1, which is the same as you probably would do in a queue. But on the right hand side, you will need to also update the pointers in the second array, and in the second array you're simply going to say, well, okay, position 0, the next item on the list will be in position 1. So let's add another item. So in this case we add item number 45. Now the start pointer is now obviously moving on to the second item because obviously that's where we've added an item, and the heap pointer moves down, so that means the heap item can be added at position number 2, and we currently keep everything as it is because 37 and 45 are in particular order. So index 0, next item is position 1 in the right hand side array, and when you go to index 1 you put the value -1 denoting that this is now the end of the list. So basically linked lists just work when updating pointers and making sure you're keeping track of what's going on the left hand side or the first 1D array, and making sure that you're updating the pointers on the right hand side or the second 1D array. So the pseudocode for setting up a linked list looks something like this. So you declare your linked list array based on whatever data type you want to store in there, and then you will have a pointer array which is again going to store just integers because pointers are going to be just integer data. You're going to declare your start pointer variable, your heap start pointer, and an index. Initial values are going to be 0 and -1 because that denotes the list is empty, and then you will use a for loop to update the indexes on the pointers because you need to have values there, and then as each value comes in, you just use the basic array assignment that linked list pointers number 11's value is -1 to denote end of list, or my linked list pointer number 2 is the -1 to denote the end of the list. So that's entirely up to you. Now this linked list structure will probably look like this. Your pointers on the right hand side based on the pseudocode we wrote, your heap pointers, and your start pointer at the beginning will be -1 because there's no value in the linked list. So make sure that you pause the video and get familiar with the pseudocode. So how do you find an item in the linked list? And again, the structure is somewhat similar. You will need to define the item you're searching for, which could be an integer, item pointer, which is also an integer. You will need to make sure that your null pointer is -1, and you create a find function which returns an integer value which either has the location of your item or -1. So set up a flag, create a while loop, and then use an if function to return the boolean value true if you find the item, if it matches, or else update the item pointers to keep checking the rest of the items and ultimately return the value back to the user. So pause the video and have a look at the pseudocode and understand it. Now, next stage is to implement this in Python. One possible implementation is on screen, so you can pause the video and just have a look at that and then try to code it. Of course, you can go online and look at other implementations as well. Lots of different ways to implement linked list. Just make sure that you're familiar with coding it in one particular way. So pause the video and then have a go at coding a linked list. A typical exam question for a linked list would have two arrays listed up like the ones you see on screen, and you will need to show the value of the start pointer and the heap pointer when 37 has been removed from the linked list and 18 followed by 75 have been added to the linked list. So pause the video and have a go and get back to me if you have any difficulties with this. Hopefully by the end of today's long lesson, you should be able to implement a record. You should be able to implement an array both in 1D and 2D and answer what the differences are between a stack, queues, and linked list. You should understand what pointers are and how you can implement them, and how stacks, queues, and linked lists are actually implemented. Now, with everything programming, the more you practice these type of questions, the better you're going to get at them. So I would probably say that try to look at some case studies of implementing linked lists, implementing stacks and queues. Have a look at some reference materials outside of the curriculum and make sure that your knowledge of implementing linked lists in particular is pretty sound. You can go and have a look at some past paper exam questions as well and find out what type of questions are asked in exams and are you comfortable in dealing with them. That's all for today, and I will catch up with you in the next lesson.